Welcome. Today, we present the validation framework for hydrocav mechanical snow systems. Our talk, Breaking the Monopoly on Ice, Disrupting the Artificial Snow Market with Explosive New Tech. For decades, the alpine tourism industry has relied on the exact same compressor-driven, energy-draining methodologies to force snow production. As student engineers and entrepreneurs, we recognize that the insulating climate crisis requires more than just an operational band-aid. It demands a fundamental disruption of how thermal phase transitions are managed in the field. Over the next 15 minutes, I will take you through how we identified a multi-million-dollar market friction point, isolated our core assumptions, systematically tested them against real-world parameters, and built a validated, highly scalable B2B business model. To understand our value proposition, we must first analyze the severe structural challenges currently impacting domestic resort operations. The problem is driven by a compounding three-part friction loop. First, we face an existential climate threat. Rising ambient temperatures are contracting natural winter seasons globally. By 2050, the Australian alpine footprint is projected to lose up to 80 days of reliable operations. This makes artificial snowmaking a baseline operational requirement for survival, rather than a luxury asset. Second, this baseline requirement traps resorts in a brutal B2B operational cost bottleneck. To keep mountains open, operators must force standard fan guns to run at highly marginal wet bulb temperatures between 0 degrees Celsius and -2 degrees Celsius.
Traditional systems rely on massive, power-hungry air compressors to atomize water droplets.
Third, this operational stress results in severe B2C consumer pain. Forcing traditional snow production at marginal temperatures creates high-density, rapidly freezing water sheets that manifest as dangerous, hard-packed, spear-like ice. This completely degrades the guest experience, causing physical injuries and equipment damage. The end result is massive customer churn, as premium local skiers abandon domestic ice rinks for international powder destinations like Japan and New Zealand. Our solution is the patented hydrocav mechanical snow system. Rather than using high-pressure air compressors or introducing foreign biological agents, hydrocav relies on the passive physics of didynamic cavitation. By passing high-velocity water through geometrically optimized venturi nozzles, we intentionally drop the local static pressure of the fluid below its vapor pressure. This creates millions of microscopic vapor cavities within the stream. As these bubbles travel into regions of higher pressure, they violently implode. From a nucleation physics perspective, these micro-implosions release powerful localized shock waves and microjets that induce extreme cooling rates of up to 10 to the 9th degrees per second. This massive energetic drop shatters the thermal crystallization barrier, forcing rapid, instantaneous primary nucleation at marginal temperatures of -1 degree Celsius to 0 degrees Celsius. Crucially, from a crystal engineering perspective, the continuous kinetic energy generated by these implosions forces continuous secondary crystal fragmentation. This prevents the water from fusing into rigid monolithic ice lattices. Instead, it shatters the freezing particles into fine, highly uniform microclusters that deliver a consistently soft, natural, powder-like crystal structure. We are effectively utilizing an industrial fluid hazard and transforming it into a definitive, unfair competitive advantage. To successfully deploy this technology, our commercialization architecture utilizes a clear dual market strategy focused on balancing short-term B2B cash flows with long-term B2C value alignment. Our immediate B2B beachhead market centers on climate-vulnerable, low-elevation private resort operators, such as Lake Mountain Resort. For a resort operations manager, the critical, non-negotiable job to be done is guaranteeing opening weekend operations to capture early season booking revenue and secure long-term seasonal viability. By targeting these specific private operators first, we bypass the heavy regulatory inertia of public peaks while solving an immediate existential threat to their baseline commercial survival. Simultaneously, our B2C strategy focuses on local accessibility. We are targeting time-poor professional families and dedicated local alpine enthusiasts who are currently dissatisfied with local conditions. Their core job to be done is achieving a premium, predictable, and above all, safe weekend recreational experience without the extreme overhead, travel time, and logistical friction of booking an overseas flight. By positioning hydrocav as a reliable local alternative, We drive recurring domestic visitation and restore consumer confidence. Every innovative business model is built on unproven hypotheses. To ensure we met corporate standards, we isolated 3 critical business assumptions to validate our viability. But first, we isolated our technical viability assumption. We assumed that the precise fluid mechanics of cavitation-based crystallization could be scaled reliably from a laboratory environment into a high-output, unpredictable alpine environment,
without losing crystal quality or experiencing physical system failures.
Second, we identified our AF assumption. We assumed veteran resort partners would be willing to alter workflows, retrain staff, and integrate hardware modifications rather than defaulting to traditional fan guns. Third, we mapped our financial realism assumption. For a B2B equipment sale, our unit economics, manufacturing margins, and equipment pricing had to align perfectly with the ROI requirements of risk-averse resort boards. If any of these 3 pillars failed to hold up under scrutiny, the entire venture model would collapse. Every innovative business model is built on unproven hypotheses. To ensure we met corporate standards, we isolated 3 critical business assumptions to validate our viability. Method 1 involved expert technical stakeholder consultations. We engaged deeply with advanced mechanical engineers specializing in industrial crystallization kinetics. This allowed us to mathematically model our cooling rates and bubble fragmentation dynamics, ensuring our core physics held up under industrial strain. Method 2 focused on B2B operational managers interviews. We conducted targeted technical interviews with veteran alpine resort managers to directly audit their actual utility overhead, daily maintenance routines, and physical retrofitting layout requirements. Method 3 utilized quantitative B2C consumer trend surveys. We deployed structured data gathering loops to a sample size of local skiers and families. This allowed us to accurately measure and quantify their willingness to pay for premium local lift passes when given a definitive guarantee of powder-quality snow surface conditions. One of the core tenets of the lean startup methodology is the willingness to let real-world evidence alter your design. Our primary data testing framework immediately forced a significant, critical operational pivot. During our field audits, we discovered a severe operational constraint: high water turbidity and heavy silt accumulation in real-world alpine water catchments. Unlike lab water, mountain reservoirs are filled with fine suspended sediments and organic debris. When this untreated water is forced through high-velocity nozzles, it causes immediate microabrasion, rapid clogging, a complete loss of hydraulic efficiency, and a high risk of catastrophic mechanical failure. We had to adapt immediately. We completely re-engineered our product architecture to include an integrated, self-cleaning dual filtration valve system. This automated flushing valve continuously clears sediment buildup without interrupting the snowmaking cycle. While this engineering modification increased our baseline manufacturing costs, it successfully mitigated the risk of mechanical downtime, enhanced long-term system reliability, and transformed an operational vulnerability into a major component of our technological durability. Our B2B operational interviews allowed us to replace the unvalidated speculative financial assumptions of our early models with concrete, data-driven unit economics. A standard high-end commercial compressor fan gun currently costs the industry between $50,000 and $70,000 Australian dollars. Because the HydroCav system entirely eliminates the need for expensive, massive, external air compressor lines, we can position our unit at a highly competitive market price point of $65,000 Australian dollars. The financial data shown on slide 8 outlines a compelling business case for a resort board. Traditional snowmaking systems consume an average of 1.6 kilowatt-hours of electricity per cubic meter of snow produced, driven entirely by the heavy load of air compression. Because HydroCav relies on passive fluid dynamics, it draws only 0.4 kilowatt-hours per cubic meter, representing an immediate, massive 75% reduction in energy consumption. For a regional beachhead operator like Lake Mountain investing in a foundational 6-unit fleet, the total capital expenditure comes to $390,000 Australian dollars. When you combine seasonal utility savings with the elimination of additives, the resort captures an annual operational savings of $160,000 Australian dollars. This compresses the asset's financial payback period down to a highly attractive 2.4 seasons. delivering verified operational efficiency alongside ironclad financial validation. Concurrently, our quantitative B2C consumer trend surveys provided the empirical validation required to confirm our market placement strategy. The consumer insights gathered definitively proved that local powder snow quality behaves as a preferred substitute for international ski travel. Our data revealed three critical consumer dynamics. First, time-poor professionals noted that a 6-hour round-trip driving investment to a domestic mountain is only viable if the snow surface remains safe and carvable throughout the entire afternoon. Second, our survey validated a massive safety concern among families. Parents explicitly state that traditional artificial snow feels like concrete covered in spear-like ice shards, which actively destroys their children's confidence and causes physical bruising. Third, by utilizing HydroCav to eliminate the ice rink effect, we unlock massive pricing power for domestic resorts. Consumers explicitly validated that they are highly willing to absorb premium domestic lift pass pricing if they are provided an ironclad guarantee of soft, reliable powder. This shift directly neutralizes the overseas flight risk, strengthening long-term brand loyalty and stabilizing regional retention rates. By synthesizing our engineering modifications, operational interviews, and consumer data, we constructed our refined lean canvas to serve as an operational dashboard for the venture. Our validated problem block focuses tightly on the high energy costs and operational inefficiencies plaguing traditional snowmaking. Our unique value proposition is completely distinct. We deliver high-quality artificial powder through an energy-optimized advanced mechanical technology that requires zero ecological additives. Our unfair advantage is structurally secured through our exclusive commercial rights to patented filtered cavitation technology, featuring our integrated self-cleaning sediment valve system. Finally, our revenue streams are structured to capture both short-term capital and long-term predictable value, combining direct B2B heavy equipment sales with recurring high-margin revenue generated from maintenance and service contracts. The components of our business model are seamlessly aligned with verified market realities. To conclude, the commercial trajectory for HydroCav extends far beyond our local beachhead. Looking at the global market context, the reliance on artificial snow has reached an unprecedented macro baseline. The extreme operational strains witnessed during elite international events, notably the 2026 Milan Cortina Winter Olympics, prove that the global industry is desperate for solutions. Alongside the massive surge in indoor snow centers across Asia and the Middle East, it's clear the global winter sports industry is desperate for sustainable, energy-efficient solutions. Our immediate next step is transitioning from empirical modeling to a localized physical pilot program. By launching a live multi-zone field pilot directly at Lake Mountain Resort, we will begin collecting long-term, longitudinal operational metrics. This data-driven validation will allow us to establish definitive performance benchmarks, prove our technical reliability under harsh, fluctuating real-world settings, and optimize our environmental specialization to meet the rigorous climate requirements of high-performance alpine sports. HydroCav isn't just saving the local ski industry. We are engineering the future of global alpine resilience. Thank you very much, and we are now open to any questions from the panel.